Welcome back, folks, to the fourth segment of this guitar archaeology series, where we'll pick up where we left off last episode with the repair stage of the restoration process. Last episode we fixed the tone switch and got the other electrical bits up to snuff. Now I will cover how I dealt with the missing tuner button, which turned out to be a bit more complicated than expected. Now the obvious answer was to procure a replacement button. I spent a couple days scouring the internet for either vintage or reproduction replacement buttons, but I could not find this style of button anywhere. Danelectro apparently only used this style on the Dolphin Nose headstock, which was only in production for 3 years from 59 to 62. Owning an obscure or rare guitar can sometimes be a double-edged sword, as parts can be difficult to find. Conceding my attempt to find an original replacement button, I began weighing all the options. I could replace the missing button with a mismatched button, which would allow me to restore functionality while keeping as much of the parts original as possible. I really wasn't too fond of this option, but it was an option nonetheless. I could replace the entire strip tuner assembly with a good used assembly from that same model. This option would mean that the guitar would have one less original from the factory part, but it would be the same part and would restore functionality and keep the proper aesthetics. This was a strong contender until I faced the same sourcing issue as the button. There were none to be had at the time and very little history of them showing up on the used market. I considered the option of replacing the tuners with higher quality tuners. The original open gear strip tuners are about as basic as they come, and from a player standpoint rather than a collector's, it may be ideal to use this opportunity to put better tuning machines on. I tend to side on the collector's viewpoint in this case, however, and would prefer to keep the guitar as original as possible. I did entertain this option enough, however, to take measurements and see if I could find some vintage style Kluson stamped steel tuners. It turns out that Danelectro used a narrower spacing than the standard spec vintage tuner, so this option was ruled out. I finally decided the best compromise would be to replace all 6 tuner buttons with vintage style oval buttons from Stuart McDonald. I went with the cream color to match the aged plastic knobs, strap buttons, and vinyl side strips. This would allow me to keep the original tuning mechanism, restore functionality, and be as visually close to the original as possible. I removed the brass wheel gears and pegs from the strip tuner base plate, then headed down to the workshop for the dirty work. I used a set of pliers to gently coax the remaining original buttons off the shafts. I wasn't sure if this would work, as some buttons are glued in place, but these were only press fit onto the spline shaft, so they came off quite easily and with no damage at all. I'll keep these around in case I happen upon a matching replacement someday and can make the change back to original. So now I'm left with 5 clean spline shafts and 1 marred shaft with corrosion and old bits of plastic stuck to it. Since the splines are missing from this end shaft, there's no way for the shaft to grip a new button, so I'm going to have to use glue. I use a wire wheel to clear away the gunk and leave a clean but textured finish for the glue to adhere to. This normally isn't a method you'd want to use, but we're making some compromises here. This shaft had a slight bend in it also, which I initially attempted to straighten with pliers. I wasn't able to hold the shaft secure enough, and I didn't want to create any more marks on it, so I opted to use my vise and a couple of planks of pine as a press, which seemed to do an adequate job. It's not dead straight, but much better than before, so it will have to do since the worm gear shafts are not removable from the base plate. Now you can see we have the strip tuner cleaned up nicely and ready for a new set of buttons. These new tuner buttons came pre-molded with a 3/32 by 5/32 inch rectangular hole with rounded ends. I measured the shaft at just a hair over an 1/8 inch, which is just over 1/32 larger than the preformed hole width. I used masking tape to mark a depth stop guide on a 1/8 inch drill bit and load it into my Dremel drill press. I secure the button in a clamp and get it aligned and centered to the drill bit, then bore the hole. Now it's time to press the button onto the spline shaft. Just as an affirmation to the authenticity of an amateur at work here, I'll proudly show the footage of me fumbling through my hodgepodge of tools attempting to find something that will accomplish this task. If you ever take a look at an actual luthier's workshop, you'll notice a variety of purpose-made tools that are engineered solely for specific jobs around a guitar. The DIY approach requires little creative ingenuity and generally a lot of compromise. Sometimes the simplest solution is the best solution, as I finally get results using basic slip joint pliers and a shop towel to protect the plastic button. But we've encountered a problem. Apparently the hole I drilled was not large enough, as the shaft caused the button to expand, which left white stress markings visible from the outside. In another proud display of amateur mishaps, I can tell you this is due to me not realizing that the measurement I took for the shaft diameter was on the damaged shaft. This shaft had been worn down and was not as thick as the other shafts with the splines intact. Luckily, I'm experienced in the art of snafu and had purchased 8 buttons in anticipation of mistakes. I took new measurements, then repeated the process with the proper sized drill bit. Now, just to add insult to injury, the Dremel tool has a 1/8 inch collet, which means the 1/8 inch drill bit I was using was the largest it could fit. I don't have a larger drill press, so the holes had to be drilled by hand. There were no further issues, luckily, and I was able to get all 6 buttons installed. The rectangular holes left just enough gap on the sides of the shaft to wick some cyanocrylate or superglue inside to further hold them into place. I head back to the guitar lounge to lubricate and reassemble the tuning gears. After cleaning all the tuning components, I used DuPont multi-purpose Teflon lubricant to lubricate all the gears and friction surfaces in hopes to get the tuners working as smoothly as possible. I inserted each tuning peg into the base plate, then aligned the brass gear to the worm gear and secured them with machine screws. I adjusted the torque on each machine screw to allow for smooth rotation of the gears. It's now time to reattach the strip tuner assembly to the headstock. I align and insert the tuning pegs into the holes, through the lubricated ferrules until the base plate is flush with the back of the headstock. I reinstall the 3 small wood screws to secure the base plate, and this repair is finished. We've made it through the disassembly, inspection, cleaning, and repairs, and now it's time for reassembly. For the sake of brevity, I did not record all of the assembly process, as much of it is the reverse of the disassembly process. At this point, the neck and body have been rejoined and all the hardware has been reinstalled. It's now time to install the strings and adjust the bridge for string height and intonation. I begin by installing the 2 centermost strings, D and G in standard tuning. I will intonate these 2 strings to get the saddle placement reasonably close, and will make fine adjustments once the remaining strings are on. I am using this method because it is much easier to maneuver the saddle with only 2 strings applying tension. Now that I have the saddle placement roughed in, I install the remaining 4 strings and make further intonation adjustments. The strings I'm installing on this guitar are Ernie Ball Power Slinky 2220 custom gauge. This set runs from 11 to 48 gauge, which on this 25-inch scale neck yields between 18 and 20 pounds per string, for a total tension of 112 pounds. The low E, A, and D use a hex-shaped steel core wire wound with nickel-plated steel wire. The G, B, and high E are plain unwound strings made of tempered, tin-plated high-carbon steel. Afterwards, I conducted a playing test and made final adjustments to the string height using a string action gauge ruler, then final intonation adjustments in the normal playing position. We're out of time for this episode, so we will finish with a final reveal and demonstration video for next time. Stay tuned!